All right, so I'm going to start working through number 36 through the end of the review. All right, so here we go. On number 36, it's talking about association versus causation. Remember, the only way it can be causation is if there has to be a 100% correlation or relationship between the two things. Like one absolutely has to cause the other, right? There's no other variables kind of getting in the way. Association means there could be a relationship, but there's probably like another variable playing its cards in the mix that is causing the relationship to show up, okay? So on part A, it says an hourly employee works more hours and therefore makes more money. Well, if you're making like 20 bucks an hour, then yeah, the more you work, the more money you make, right? That is definitely causation. Right? Working more hours causes you to make more money, right? That's just a direct relationship. Number 2, the weather gets colder and more people become sick. That would be an association, of course. Right? The common variable there being when it gets colder outside, more people stay indoors, right? And the more people you have indoors, the more germs you're sharing that are trapped inside. Right, so that would be, there is a relationship there, of course, but it's not, one is not causing the other. All right, number 37 is going to be our linear regression. And I know this because it says right here to create an equation that represents the line of best fit, right? Otherwise known as a regression line for a scatter plot. Right? So we are totally going to use Desmos for this. Let me write that down. All right, we totally want to use Desmos for this problem. Okay, so I'm going to kind of hop back and forth here really quick. I'm going to go to my Desmos. There we go. I'm going to clear out everything that's in there. All right, so the first thing you want to do, of course, is put the information in the table. Okay, so I'm going to add a table. All right, let me enter all the X values really quick. So you definitely, as you're typing it in or before you even type it in, you want to pay attention to what you're actually typing in. Like what is this table even giving me? So if you read the problem, right, it is talking about a survey was given where it had a bunch of famous people and people were guessing their age. And then comparing those guesses to the famous person's actual age and seeing how close or how far people were. Now, there we go. Now, I like to hit the little plus sign magnifying glass, and it'll kind of make a nice pretty window to see all of our 7 data points. So you can see it's pretty tightly correlated, which to me says that people did a pretty good job of guessing people's actual ages, okay? So that is our scatter plot. Now I'm gonna ask the Desmos to run a linear regression. So I'm gonna go to the second line, and this is where you're gonna type in Y1, and then the little squiggly, little approximation there, because we're running a regression, and then MX plus B, but we need to be MX1 plus B. B. And then as soon as you type that in correctly, then you should see this whole box of statistical data that shows up underneath there. If you've done something wrong, then you won't see the box. Also, if you see only a bunch of zeros and ones, you've also done something wrong, right? You should have a lot of crazy little decimals and all that good stuff. All right, and so basically, I'm going to copy down that information, right? The only 3 pieces of information I really care about in that box are the R value, which is that 0.986, and then the M and the B, which is giving me the slope and the y-intercept, right? So I'm going to take that information. I'm going to go back to my review here. I'm going to write all that down. All right, so here we go. I'm just going to write the M value, right? So it gave me 1.1444, and then the B value gave me negative 4.30143, and then the R value was 0.986. Now I know I didn't ask you to find the R value, but I'm going to talk about it anyway. All right, so of course what we want to do is we want to use the m and the b to write our linear regression equation, right? So y equals, and you can just kind of round to 2 decimal places if you want to. If you want to put them all in there, you're more than welcome to. So about 1.19x minus 4.3. Right, and that is our line of best fit. Again, never ever round to the nearest whole number, right? Because, and if you want to put a 0 on here, you can. We never round to the nearest whole number, right? Because these decimals are actually infinite, right? So just rounding to 2 decimal places, we're getting a ton of rounding error in our final answer. So we want to go out a minimum of 2. And then lastly, I want to talk about, I know I didn't ask you to do this in the problem, but I want to talk about that R value again really quick. So remember the R value of 0.986, that tells me how tightly packed and how closely related the X and the Y variables were, which again means that we guessed really well for those celebrity ages. And so we would say this as a strong, because they're tightly packed, but we also want to say positive because it's a positive 0.986, which is because our slope is increasing, a strong positive correlation, right, between X and Y in this problem, okay? All right, number 38, Mike bought 5 items for lunch that cost a total, I like when I'm given totals. Right, this is a word problem, so whenever I see a total, that implies that my equation will be written in standard form. Hot dogs cost $1.10 each, cookies cost 75 each. Write a system of equations that can be used to determine H, the number of hot dogs, and C, the number of cookies. All right, so I like to write my variables down here, so even though they told me in the problem, right, so number of hot dogs, and C is number of cookies. All right, so let's see. Remember, anything pertaining to money all has to go together. So the $4.55 definitely has to be in the same equation as the $1.10 and the 75 cents each, okay? All right, so we're going to put all that in the same equation. So let's see, hot dogs are $1.10, so $1.10 per hot dog plus 75 cents per cookie equals a total of $4.55. Right, so that's our first equation. And you might be thinking, where's the second equation coming from? I don't see another number, but it's right here. Right, he bought a total of 5 items for lunch. Right, so that's going to give us the equation H plus C equals 5. Right, because H and C stand for the number of hot dogs and cookies he bought. So that equals 5 total items, right? So we've got money plus money equals money, and number of things plus number of things equals total number of things, okay? And there you go, there's your system. We're not asking you to solve it, we just want you to write it down. All right, number 39, Charlie is making a rectangular picture frame. The height of the frame is 6 inches longer than its width. The perimeter of the frame is 76. Write a system of equations that best describes the dimensions of the picture frame. Okay, so again, remember, we've got a rectangle. If you, instead of saying, I don't like that it even used the word height, if you want to just say length instead of height, you're more than welcome to. Right, so we know on a rectangle there's 2 lengths and there's 2 widths. Right, we talked about this many times before. All right, this first sentence, let's see, let me define my variables. So I'm going to make L the length, or you can use H for height if you want to keep it as height. And then we have width. Again, you can use X and Y or L and W, H and W. Again, your variables can be whatever letters as long as you know what they stand for. All right, so our first sentence, the length of the frame is 6 inches longer than its width. All right, so anytime you see words like longer, more than, less than, twice, right, these are written as you read it sentences, in which case you want to find the is because that is your equal sign. Right? So the length is, okay, so L equals 6 inches longer than width. Okay, so width plus 6, or 6 plus width. Either direction is totally fine. And then our second sentence, the perimeter is 76. Well, remember, we need to go find the perimeter of a rectangle, right? And so that's going to be 2L plus 2W. And that equals 76, right? You got to know that perimeter of a rectangle formula, right? Because you're adding up all the sides. And there you have it. There is your system. All right, our last few here, we're going to graph the system of equations. All right, so we're going to solve by graphing. The first thing I notice when I'm trying to solve this system of equations is I totally want them in y equals mx plus b form. Right, and neither one of those is. So we've practiced this oh so many times, right? And so I'm going to go ahead and, let's see, I'm going to use two different colors here. So we're going to add the x. Right, you always move the x term to the other side. Those cancel. And that's how we're going to get y equals positive x plus 2. I always like to put my x first. You can write 2 plus x if you want. It's the same thing. But just by now that it's in y equals mx plus b form, I know it has a y-intercept of 2, and then I'm going up 1 over 1. Remember, we want our lines to be nice and straight, right? On your test, grab a ruler or whatever you need. If you need help drawing more straight lines, then that's what rulers are for. All right, so here's that line. All right, then we're going to go graph our second equation, which is also not in y equals mx plus b form, right? Because we need to move the x term to the other side. And that is going to give us y equals negative 3x plus 6. Right. And I'm going to graph that guy. So he starts at 6. And he has a slope of negative 3 over 1, so down 3 over 1. And of course, that's the point I'm looking for, right? When we solve a system, we're looking for the one point that they have in common at the same time, which is going to be their point of intersection. And so we are totally looking for this guy right there, right? That is our solution. I'm just going to write that down. Right, and what is that point? Over 1 up 3, right? So 1, 3. You can also put that into Desmos, remember, as long as it's in y equals mx plus b form. You can put those two equations in Desmos, have it graph it, just to make sure you didn't make a silly graphing mistake, and then just tap the intersection point, and it will tell you exactly what that coordinate is, just in case you don't mess that up too, right? So always use Desmos to check your math if you've got time, okay? All right, the next question is graphing the system of linear inequalities, right? And again, we totally want these in y equals mx plus b form. And please remember, in our notes, we had those 6 things to remind you about inequalities, right? It's either a dashed line or a solid line. We shade above, we shade below. If you divide by a negative, you have to switch the inequality symbol, right? So there's a lot of little minute details that you have to remember about graphing systems of inequalities, okay? So our first one, luckily for us, he's already in y equals mx plus b form. Yay, right? And so there's an understood plus 0 hanging on the end there. So he has a y-intercept of 0. You know what, before I do that, I like to go ahead and kind of analyze. That is a less than or equal to. So the fact that it's an equal to bar, that means it's a solid line, because I can actually equal the points on the line. And it's a less than. Why is everything less than the line? So we are going to shade below. So solid line, shade below. I like to kind of get that set before I draw my line. So we have a y-intercept of 0, again, because there's not a constant hanging off the end. And then our slope is 2 over 1. So we're going to go up 2 over 1, up 2 over 1. Again, nice straight lines, nothing sloppy. Solid line, right? And then we're going to shade everything below, right? So if you have trouble with that, put your pencil on the line, and then it's below. That means we're taking our pencil down, right? And so the side that you're shading, right, when you drag your pencil down below the line, right, is going to be this side right here. This is going to be all of our lesser y values. Okay, so I'm just going to shade this region because that's where all the infinite solutions lie for that inequality. Okay, and I'm going to go do the other one. Let's see. I'll use orange on this one. He's not in y equals mx plus b form, so we do need to subtract the x to the other side. All right, and that's going to give us y. I'm not going to flip the symbol because I did not divide by a negative, right? But if I do, I would want to make sure I switched it. Oops, sorry. And that would be negative x. Then I'm going to kick my positive 3 out to the side. So there's our slope-intercept form. I do want to take a note that this is a greater than symbol. Does not have the equal to bar, which means he's going to be a dashed line. And he's greater than, which means we'll be shading above. So dashed and above once we get that line drawn. All right, so let's see, plus 3. So our y-intercept is here. Our slope is -1 or -1 over 1. So we're going down 1 over 1, down 1, right 1, down 1, right 1. All right, or I can go backwards this direction. There we go. I'm just going to put little dashes in between those dots. There we go. There's our dashed line. And we want to shade everything above, right, which would be this direction for him. And then you're not quite done because you want to make sure it's very clear, right? We want where the solution to the two inequalities or the system is where they overlap, right? And so it should be pretty clear that my two shaded regions are sharing this space right here. And I kind of highlight it in yellow so it's super obvious, right? And then we just want you to, obviously there's infinite solutions that work and infinite solutions that don't work, right? So if we want to name a solution point, all right, so anything, here, that is our solution region right there for the system. So just pick any point in there. I'll pick this guy right here, right? That's the point 6, 2, right? He is in my solution region, right? Let's see here. Oops. Sorry, I wanted to red one. A non-solution, you could either pick a point in here because he's not a solution to both. You can pick a point in here because he's not a solution to both, or you could pick a point over here. As long as it's not in that yellow shaded region, right, then you can pick any point you want. I'm just going to pick this point right here for no good reason, just because, right, and that's the point -4. That's what we're looking for, -4, 3. All right, number 42. The table below shows the rates for 2 duplicating companies. For what number of pages will the 2 duplicating stores charge the same amount? All right, so basically on that question right there, it's just telling you to solve the system. Oops. There we go. That's right. All right, we have 2 different stores, so this is saying solve the system of equations. And you're like, but I don't have a system of equations yet, right? Because you have to write your own, right? And so it says it's giving you the initial fee. So Quick Copy charges $5 up front and then an additional 6 cents per page. And then Copy Palace, right, charges an initial fee of $10. That's a lot, but then they only charge you $4 per page. Okay, and I'm hoping as you say that, or I said that out loud, you recognize right away that the initial fee is their starting amount, which would be the y-intercept. And of course, the amount of money they charge per page, right, that is totally going to be our slope, right? So they're essentially giving you the y-intercept and the slope, which means we can write these in y equals mx plus b form, right? So for Quick Copy, it's going to be y equals 0.06 cents per page plus the initial $5 up front. And then Copy Palace is going to be 0.04 cents per page plus the upfront $10 cost. So there's our system right there. And they want us to solve that. Well, we've only learned to solve by graphing, and it's in y equals mx plus b form. I noticed they didn't give me a graph, which means Desmos to the rescue, right? I'm totally going to use Desmos to help me out here because I have to graph it, and they didn't give me a graph. So here we go. I'm going to go back to Desmos. Let me clear out my regression stuff, and I'm just going to type those 2 linear equations in, right? So here we go. Y equals 0.06x plus 5, right? So there's quick copies equation. And then on line 2, y equals the 4 cents per page plus the initial $10. Now I'm going to kind of manipulate my graph a little bit because obviously I'm going to have to copy a lot of pages, right? There we go. I'm going to kind of move the window of my graph around so that I can see, right? I can clearly see that up until this point, oh, you can't see that. There's our intersection point, which is of course our solution. But up until that intersection point, right, quick copy is the bargain because they're the lower line, which means the lower cost, right? But then once I surpass that point, 250, 20, then copy place, was I saying palace? Anyway, copy place becomes the better deal, okay? So I'm gonna go back. So remember that point, 250, 20. All right, so Desmos, right, told me that my solution was 250, 20. Right, that is our solution. And we need to understand what that means, right? Because X represents the number of pages, right? Because it was charged per page, right? Number of pages, right? And then the Y value represents the total cost, right? So I'm just going to write a little sentence here. After 250 pages, both places charge $20, right? And just understanding that that is how many pieces of paper or how many copies to make before they actually cost the exact same, which is what it was asking us to find. All right, number 43, the student band collected 2,892 for 480 tickets sold to their spring concert. Adult tickets were $8 and student tickets were $5. Okay, I'm going to stop right there because I'm going to do my variables. I'm going to use X for number of adult tickets. And I know it's number of adult tickets because they already told me the cost, right? So when it's an equation like this, it's either going to be number of them or cost of them, and they already told me the cost. So I don't know the number of adult tickets, and then I'm going to have Y be the number of student tickets. Right, and it looks like they totally gave us a total, which means these are going to be in standard form, right? So they gave me a total amount of money, and he only can go with the other money, right? Money plus money equals money, so all the money has to go together. So it's $8 per adult ticket, so 8x, plus $5 per student ticket, and that equals $28.92. Money plus money equals money, right? And then we have the total tickets. Well, X and Y stand for ticket numbers, so X plus Y equals 480. And that is our system of equations, right? Well, if we're going to solve that, we need to actually do the work in order to solve it. So we've only learned the graphing method, which means I'm going to use Desmos. I'm going to scooch. Oh, I didn't mean to grab the Y. Hold on, let me try that again. There we go. I'm going to scooch this equation over here because I clearly need to put these in Y equals mx plus b form so that I can put it into Desmos. All right, so really quick, I'm going to put my first equation in Y equals mx plus b form. It's probably not going to be the best looking equation, but that's okay. 5y equals negative 8x plus 2892. And then I need to divide every single term by 5. And again, we're kind of forced to solve it this way because we've only solved by graphing so far, right? When we come back from spring break, we will learn other methods to do this problem. Now, obviously my slope, I can't do anything with the negative 8 over 5, and it's okay that it's a fraction because it's slope, and slope is rise over run. It's supposed to be a fraction. All right, I'm going to divide 2892 by 5. And that gives me 578.4. I just threw that in my calculator. All right? So there's that in y equals mx plus b form. Okay, and then I need to get the other equation in y equals mx plus b form. He's much easier because I just need to subtract the x over, right? So y equals negative x plus 480, and that's his equation. Okay. All right, I am now going to go put those into Desmos really quick because obviously we don't want to graph that mess by hand, right? And so we're going to have Desmos do the work for us and go find the solution. All right, so I'm going to go back here. Let me take out those equations. Here we go. Y equals negative 8/5. Just hit the division button. Don't forget to hit the right arrow, though, to kick out of the fraction. Plus 578.4. Okay, and then our other equation was y equals negative x plus 480. All right, and now notice our lines, of course, they're going to be intersecting way up here, so manipulate that window so you can find it. And then I can just bloop, tap on the intersection point, and it's going to tell me exactly what their solution is, right? So 164, 316. Okay, I'm going to go back here. 164, so 164, 316. Right, this was the solution that Desmos gave us. Right, so Desmos, yay. Right, and that's our solution. But you got to be really careful because the actual problem said how many adult tickets were sold. And remember, adult tickets was X. So that means the only part of our actual intersection point that we want is the 164, right? So I'm going to write X equals 164 adult tickets. Right, and that's our final answer. Okay. All right. Really quick, I'm just going to fly through these last few because I only have a couple minutes. So remember, the linear parent function is y equals x, right? So that means all your x's and y's are the exact same value, right? And so when I plot those points, we all know what y equals x looks like, I'm hoping, right? It has a y-intercept of 0 and a slope of 1, which means your y-intercepts, your x and y-intercepts are 0, 0. Remember, zeros just means the same thing as x-intercepts, right? It's just another word for x-intercepts, right? So 0, 0. Our domain is all real numbers because it goes forever left and forever right, and our range is also all real numbers because it goes forever up and forever down. Okay, next one, quadratic parent function is y equals x squared. So we're going to take all the x's and square them, which gives us these numbers. And when we plot those points, negative 2, 4, again, be neat with it. Don't just slap points around. You just can't draw some random U-shaped graph, right? They have to go through these points, right? So I'm going to draw a U-shaped graph and try to, manipulate that just a little bit. Oh, goodness gracious. I'm going to have to. My goodness. Never mind. Good enough. Okay. So his x-intercepts are, of course, 0, 0, y-intercept 0, 0. And again, roots is just another fancy word for x-intercepts, right? We're just reiterating that vocabulary, right? So 0, 0. And then lastly, the exponential parent function. We haven't talked about this one in a while, right? 2 to the x power. Right, so when you do 2 to the negative 2, and you can just use your calculator, that gives you 0.25. This 2 to the negative 1 gives you 0.5. 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. So remember, this is that one where you're never going to reach the x-axis, right? So 2, 4. So it just keeps growing and growing and growing as it goes to the right. But as you graph your values here, it's just going to get closer and closer, but never, ever, ever reach the x-intercept, right? Which means it has no x-intercepts. The y-intercept is at 0, 1, right? You can see that in the table and the graph right there. And then again, zeros is just another name for x-intercepts, right? So none. Okay. All right, so just make sure you know your parent function equations, right? You can even type those into Desmos if you know them, but if you don't know the equations, it's really hard to make the table or use Desmos to help you out. All right, I hope all of those questions make sense. Obviously, if there's time in class to ask questions, I encourage you to do so. All right, see you soon.